أهلا وسهلا بالجميع. محاضرة اليوم بعنوان Frequency Modulation. في هاي المحاضرة ومجموعة المحاضرات القادمة رح نتعرض للانجل موديوليشن، وتحديدا رح يكون تركيزنا على الفريكونسي موديوليشن. ففي هاي المحاضرة رح نحكي فقط عن البيسك برينسيبلز للفريكونسي modulation. To generate an angle modulated signal, the amplitude of the carrier is held constant while either the phase or the time derivative of the phase is varied linearly with the message signal. Let the unmodulated carrier C of t be AC cosine 2 pi fct. AC is the constant amplitude, Fc is the unmodulated carrier frequency. So in this type of modulation, we will add a term augmented with 2 pi fct that carries the information pertaining to the message signal. So the expression for an angle modulated signal is S of t equal AC cosine 2 pi fct plus theta of t. This is the phase difference which we add to the unmodulated phase of the message or of the carrier C of t. Here, this added term will contain the information pertaining to our message signal. So theta of t is a phase difference that contains the information message. Fc, of course, is the unmodulated carrier frequency in hertz. The instantaneous frequency of this signal S of t is Fi of t equal 1 over 2 pi d by dt of 2 pi fct plus theta of t. Fc, the derivative of 2 pi fct, is 2 pi fc. When we divide it by 2 pi, we have only fc plus 1 over 2 pi d theta by dt. So for this type of signal, the instantaneous frequency is Fc plus 1 over 2 pi d theta by dt. Since the information is contained in the phase, this type of modulation is less susceptible to additive wide Gaussian noise and interference from electrical equipment and the atmosphere. We notice that the information is hidden within the phase angle, so it's less susceptible to noise, while in amplitude modulation, the information was carried in the amplitude. For phase modulation, the phase theta of t, this quantity, is directly proportional to the modulating signal. So theta of t equal a constant of proportionality, Kp times m of t. Kp is the phase sensitivity measured in radians per volt. So for a phase modulated signal, this phase difference theta of t is made proportional to the message signal. As such, the time domain representation of a phase modulated signal is this equation, S of t equal AC cosine 2 pi fct plus Kp m of t plus Kp m of t. So this is the standard equation for a phase modulated signal, a constant amplitude, and the phase difference theta of t is proportional to the message signal. Now, to complete the picture for the phase modulated signal, the instantaneous frequency Fi of t can be computed from this fundamental equation. Fi of t equal Fc plus 1 over 2 pi d theta by dt. So d theta by dt equal Kp dm of t by dt. So for a phase modulated signal, the instantaneous frequency Fi of t equal the unmodulated carrier frequency Fc plus a term which is proportional to the derivative of the message signal, Kp over 2 pi dm of t by dt. So these are the three equations that govern the phase modulated signal. First, the phase difference is proportional to the message, Kpm of t. The second one is the time domain representation of the phase modulated signal, which is AC cosine 2 pi FCT plus Kp m of t. And the third equation, which specifies the instantaneous frequency as Fc plus Kp over 2 pi dm of t by dt. الآن بنكمل على phase modulation. Again, this equation, the angle modulated signal is S of t equal AC cosine 2 pi FCT plus theta of t. And the instantaneous frequency is Fc plus 1 over 2 pi d theta by dt. الآن بنحكي على النوع الثاني من الانجل modulation, which is frequency modulation. For frequency modulation, the frequency deviation of the carrier is proportional to the modulating signal. Now, 1 over 2 pi d theta by dt, 1 over 2 pi d theta by dt, this is the frequency deviation, which means the difference between the instantaneous frequency and the unmodulated carrier. This quantity is called the frequency deviation. So for an FM signal, this quantity is made proportional to the message signal. So we have 1 over 2 pi d theta by dt equal K sub f times m of t. K sub f is the modulator sensitivity in hertz per volt, and when we integrate both sides of this equation, we have theta of t equal 2 pi K sub f integration from 0 to t m of alpha d alpha. So the instantaneous frequency now becomes, this quantity is Fc plus K sub f times m of t. So for an FM signal, the instantaneous frequency is made proportional to the message signal. So we have this linear relationship between the instantaneous frequency and the modulating signal m of t. So the frequency deviation is proportional to the message signal, or the instantaneous frequency is also proportional to the message signal. Of course, the difference between the instantaneous frequency and the unmodulating carrier frequency, Fi of t minus Fc, equal the frequency deviation K sub f times m of t. The peak frequency deviation, which is the maximum value of this quantity, is delta F, denoted by delta F equal the maximum value of K sub F M of T. As for the time domain representation of a frequency modulated signal, S of T equal AC cosine 2 pi FCT plus theta of T, and this is the equation for theta of T for an FM signal. So we have AC cosine 2 pi FCT plus 2 pi KF integration from 0 to T M of alpha d alpha, and this is the phase difference theta of T equal 2 pi KF integration from 0 to T M of alpha d alpha. على سبيل المقارنة, التime domain formula for the phase modulated signal is AC cosine 2 pi FCT plus KP M of T. So the phase difference is proportional to the message signal. As for the frequency modulated signal, the phase difference is proportional to the integration of the message signal. So this is a fundamental difference between phase modulation and the frequency modulation. Finally, the average power of an angle modulated signal. This is a sinusoidal signal, and the average power is just the amplitude square divided by 2. The average power is just AC square over 2 and is constant and dependent of theta of T, whether our modulation technique is frequency modulation or phase modulation. خلينا ناخذ مثالين على توضيح للفريكونسي موديوليشن وللفورمولاز اللي مرقت معنا سابقا. فبنبدأ بالمثال الأول, which is binary frequency shift keying. Example: the periodic square function M of T shown below frequency modulates the carrier C of T equals AC cosine 2 pi 100T to produce the FM signal S of T equal AC cosine 2 pi 100T plus 2 pi K sub F integration M of alpha d alpha. KF equal 10 Hertz per volt. So we need to find and plot the instantaneous frequency Fi of T and find and sketch the time domain expression for S of T. الجزء الأول اللي هو الانستانتينيوس فريكونسي Fi of T, عندنا العلاقة الأساسية اللي بتحكم الفريكونسي موديوليشن إنه الانستانتينيوس فريكونسي هو عبارة عن constant اللي هو ال unmodulated carrier frequency plus a term which is proportional to the message M of T. So this is the instantaneous frequency FC plus K sub F times M of T. فالمطلوب منا إن نرسم هاي الفانكشن in terms of or as a function of T. فالمسج M of T is a periodic square function which assumes the values +1 and -1. TB, usually this is the bit interval, this is the time allocated for transmitting either digit 1 or digit 0 in a binary digital communication system. فهاي هي TB. فبين الصفر والTB M of T takes on the value +1. So M of T is +1 between 0 to TB. We substitute this +1 into this equation. So for T between 0 to TB, the instantaneous frequency equal 100 plus K sub F which is 10 times plus 1 equal 110. So during this time, the instantaneous frequency equal 110 Hertz. This is the instantaneous frequency. This is the message. For t between TB and 2 TB, m of t equal minus 1. So the instantaneous frequency equal fc plus k sub f times m of t. M of t equals minus 1 times k, which is 10, and we have another fc, so we have 100 minus 10 equal 90 Hertz. So over this time period, the instantaneous frequency is 90 Hertz. And again, the function over this time interval between 2 TB and 3 TB becomes plus 1, so the instantaneous frequency is 110. So in a digital communication system, we will see that a binary one may be represented by a signal of frequency f1 for t between 0 and TB, and binary 0 by a signal of frequency f2 for t between 0 and TB. This type of digital modulation is called frequency shift keying. إذا لما نبعت digit 1 هاي digit 1 بتترجم لتردد مقداره 110 هرتز. لما نبعت digit 0 بنبعت بقابلها تردد مقداره 90 هرتز. من معرفة الريسيفر بالفريكونسيز المرسلة اللي هي 110 وال90 بيقدر يسترجع المسج سيجنال. فإذا وصلته تردد مقداره 110 فبيعرف إنه اللي أرسل هو ديجيت 1، وإذا وصله تردد مقداره 90 هرتز فبيعرف إنه اللي أرسل هو عبارة عن ديجيت 0. فهذا النوع من الترانسميشن اسمه فريكونسي شيفت كينج، يعني الفريكونسي اللي عندنا بتنقل بين قيمتين حسب المسج اللي عندنا، حسب الباينري مسج اللي عندنا. إذا كان عندي باينري ديجيت 1 بعمل ترانسميشن لفريكونسي F1، إذا كانت عندي ديجيت 0 بعمل ترانسميشن لفريكونسي F2. فهذا هي النوع أو المثال الأول. هلا بنشوفه بشكل مفصل أكثر. فالآن حكينا من شوي إنه for t between 0 to TB, when the message is +1, the frequency is 110 Hertz, and when the message is -1, we transmit a signal with carrier frequency 90 Hertz. So this is our transmitted signal. It's a sinusoidal signal with constant amplitude. The amplitude is constant. However, the frequency of the signal over this time period is different from the frequency of the signal during this time period. Over this time period, we transmit a signal with frequency 110. Over this time period, we transmit the carrier, the same carrier, but now we change the frequency of the carrier to 90 Hertz, and so on. Here we have 110, 90 Hertz, 110, and so on. So the frequency or the instantaneous frequency hops between two values, 110 and 90 Hertz, as shown in the figure. فإذا هاي هي الاكتوال ترانسميتد سيجنال. هاي الترانسميتد سيجنال هي اللي بتحتوي المعلومات اللي بتتعلق في باينري ديجيت 1 وباينري ديجيت 0، وبالتالي مطلوب من الريسيفر إذا استقبل هاي السيجنال يعرف إيش المعلومات اللي أرسلناها. هل أرسلنا له داتا بتتعلق بديجيت 1 ولا داتا بتتعلق بديجيت 0. فهذا المثال الأول أو التطبيق الأول على الفريكونسي موديوليشن. المثال الثاني رح ناخد المسج سيجنال، بدل ما كانت سكوير فانكشن مثل المثال السابق رح ناخد sinusoidal signal m of t equal am cosine 2 pi fm t. So this is our modulating signal. This is our message signal. So the instantaneous frequency is زي ما شفنا سابقا في ال FM, the instantaneous frequency is linearly proportional to the message signal. So the so Fi of t equal Fc plus k sub f times m of t. So we replace m of t by am cosine 2 pi fmt. فإذا instantaneous frequency Fc plus am k sub f cosine 2 pi fmt. See, this is the instantaneous frequency. It's proportional to the message m of t. في هاي الرسمة this is the time axis and Fc is the unmodulated carrier frequency and this blue line is the instantaneous frequency. This is the magnitude of the instantaneous frequency at t equal to 0. At t equal to 0 Fi equal Fc plus am k sub f. Then the message starts to decrease. When it reaches -1, the cosine becomes -1. The instantaneous frequency drops to Fc minus am times kf. So the maximum value of the instantaneous frequency is Fc plus am kf. The minimum value is Fc minus am kf. The maximum deviation of the instantaneous frequency from the unmodulated carrier frequency, this is called the peak frequency deviation, and the peak frequency deviation is just the difference between the maximum and the unmodulated frequency, which is am times kf. So the peak frequency deviation is k sub f times am. The time domain expression for S of t is S of t equal AC cosine 2 pi fct plus 2 pi kf integration from 0 to t of m of alpha d alpha. Okay? Now S of t equal AC cosine 2 pi fct plus 2 pi kf. Now we have m of t am cosine 2 pi fm alpha d alpha and the integration from 0 to t. Integration of cosine is sine and then we divide by omega m, which is 2 pi fm. 2 pi cancels out with this 2 pi, so we have k sub f am divided by f sub m sine 2 pi fmt. K sub f am, this is the peak frequency deviation, k sub f am. This is delta f by fm, and this quantity is called beta, or the fm modulation index. So S of t equal AC cosine 2 pi fct plus beta. This whole ratio is called beta sine 2 pi fmt. Beta is called the FM modulation index and is defined as the peak frequency deviation divided by the message bandwidth or the message frequency. So beta is by definition equal this delta F divided by the message frequency FM or the message bandwidth. فهاي إذن العلاقات الأساسية اللي بتتعلق بهذا المثال اللي هي الأولى إنه the instantaneous frequency varies or has the same shape as the message signal. The instantaneous frequency has the same shape as the message signal. الثانية the time domain formula for the modulated signal is AC cosine 2 pi FCT plus beta sine 2 pi FMT. So this is the time domain representation of an FM signal. في هاي الرسمة بنشوف المسج signal AM cosine 2 pi FMT. أخذنا signal message signal with frequency 100 Hz وamplitude 1 فرسمنا المسج signal M of T. اوكي ايضا رسمنا المودulated signal S of T equal AC cosine 2 pi FCT plus beta sine 2 pi FMT. فهاي اللي فوق هي عبارة عن المودulated signal عبارة عن S of T. هاي المسج اللي فوق إلها الانستانتينيوس فريكونسي FC plus AM K sub F cosine 2 pi FMT. This is the instantaneous frequency of this modulated signal. مثل ما احنا ملاحظين الفريكونسي الانستانتينيوس فريكونسي is not constant. بمعنى انه اذا بنركز في هاي الرسمة بنشوف البيريد مش ثابتة. يعني البيريد اللي هي بتفصل ما بين 2 peaks أو 2 valleys مش ثابتة تتغير. هاي مثلا هاي المسافة لما كانت السيجنال في النيجاتيف، فلما كانت السيجنال في النيجاتيف الفريكونسي كان بياخد الانستانتينيوس فريكونسي كان بياخد أقل قيمة ممكنة، فالفريكونسي كان بياخد أقل قيمة بمعنى إنه البيريد كانت تاخد أكبر قيمة ممكنة. في هاي الفترة كمان بنشوف إنه البيريد طبعا هاي البيريد بتبدأ تصغر شوية كل ما السيجنال زادت، لأنه كل ما الامبليتيود للسيجنال بيزيد كل ما الفريكونسي بيزيد وبالتالي البيريد بتقل. فبنبدأ من هاي النقطة. هنا البيريد عندي ماكسيمم، بعدين بتصغر أكتر، بتضل تصغر لغاية ما توصل لأصغر قيمة ممكنة لما المسج تكون أخذت الماكسيمم فاليو. بعد ما تبدأ المسج تصغر بتبدأ البيريد بتزيد شوية لغاية ما توصل مرة تانية للماكسيمم فاليو لما المسج اللي عندنا بتاخد المينيمم فاليو اللي هي طبعا بتتحقق لما الكوساين بيكون سالب 1. فبنشوف when the message signal is maximum, the instantaneous frequency is maximum, and when the message signal is minimum, the instantaneous frequency is minimum. Or when the message signal is minimum, the period of the modulated signal is maximum, and this period starts to decrease as our message signal increases. So this is the highest value of the period. As the message signal increases, the period monotonically decreases until it reaches its smallest value when the message is maximum. As the signal starts to decrease, the period of the FM signal starts to increase again and so on. فهاي البيهيفير للفريكونسي modulated signal. فأخذنا مثال في هذه المحاضرة عن المسج سيجنال لما كانت periodic square function. أخذنا كمان مثال آخر لما المسج سيجنال sinusoidal signal. في المحاضرة القادمة راح ناخذ كيف بنوجد المودوليتد سيجنال، كيف بنحللها في الفريكونسي دومين، وبنوجد الباندويث للسيجنال، وندرس امور اخرى بتتعلق في الفريكونسي مودوليشن. فهاي نهاية المحاضرة، الى اللقاء.